Okay, so the faster than light, whatever it is, yeah, finally started working. The soundtrack started working. I don't know why. I didn't buy the game. I thought you're supposed to buy the game in order to play it, but whatever. So, anyways, we have a few things we might work on. I've got a few things that I want to work on. Another thing I wanted to do was adjust the asteroids. Let's go to space! Are we there yet? We are. Okay, we are. Okay, so here we are. Traveling around, we got this. Okay, one thing we could do would be, and I adjusted the moons, so the moons are a little bit more tighter around the planet instead of off into space. And because when the planets were close together, it was unclear which moons were for which planet. So I think that helps a little bit. It looks like we got some that are close together. That's fine. We're not going for realistic. We're going for cool. That's cool. Okay. Okay, so see what the asteroids look like. Okay, I think they're a little bit too detailed. So can we tone that down just a little bit? Let's go look at the asteroids. Now there's that. There's crystal 1. Okay. So maybe we'll keep this code and then we'll just do a crystal 2 or something. Set grid based on the type. For each pixel, find radius and discard fragments outside the circle radius. Determine the grid cell in the radial direction. Okay, so grid base times. Calculate the angle factor. Determine the grid cell in the angular direction. Angular grid cell floor angle factor times pi plus a10. Okay, so this. Set up the random factors at max radial grid. N1 angular grid cell divide by 100 times grid base times 0.5. Grid base half equals grid base divided by 2. If the radial grid cell is near the center, discard. If it's outside the random area, discard. Compute the color using hash function. Radial grid cell, angular grid cell. So the radial grid cell is the radius. Okay, so everything's based on the grid base. So what are we sending in for the grid base? Okay, so the grid size type. Wait, are we specifying or is it what's in the grid base? Grid type.x. Oh, it's the same. Oh, that's why. We don't want it to be like that. No. I tell you what, the size is so... Well, 12 plus random 6. See, the size is like, we don't even need that. Okay, we need the random 69 because we need those textures. But the size here... Hold on. Because what we could do is grid type. Oh, we can use the color. Okay, hold on. We can use the color. Because we don't use the color at all right now because of the texture. Okay, great. That's a great idea. And then we're gonna... Oh, this is kind of crazy. We'll have to... Maybe we should, redo some of this, but we're redoing everything. I don't know. Okay, so the color, let's go GLM vector 3. So let's try this. Okay, we're going to send in... Let's just do... Because right now they're going... 0 to 68. That's not good. Let's just do like 8. Okay, comma 0, comma 0. There. So we're going to send in a color. Okay. Now the thing is with the grid size type, If it's 8, then we know it's a crystal. So we need space planets. Ah, computer, I can't see. 120, pardon me. Pardon me. Too much coffee. Okay, so grid size type here. So grid type. Okay, so now we're going to change this. Let's go. This is going to be a fundamental change, and we might break it. So let's just change to 121. Let's get the game document out of there. Let's go to 120 here. Save that. 121. Okay. Then that means we have to go into here. We have to go into here. Do class inits. Oh, this is 227. Get that out of there. Go away. Go away. I did a double take there. I was like, what are you doing? Excuse me. Okay, 121. I just had some carrot juice. Delicious, delicious stuff. Okay, so with that and everything, so class planets we're going to send in color are, okay, so here we go. Let's change this to out grid 3. So that means in here we're going to change it to in grid 3, which means all this stuff has to change, but just hold on just a minute. So we're going to set it to 8. I know the other one's 8, but this is just to try it out. So the color is in the R variable, the type or the grid that we want. Okay, so grid type equals AGXZ. Okay, and I use that in the thing. I use that as XY. So we're adding a Z variable. So we're going to go like this: vector 3. That's the vector 2, and then we're going to go a color dot R. All right. For the other ones, we're not going to even use that, so. And then in here, we have to adjust every instance of grid type. So find, oops, no, control F, excuse me, pardon me, excuse me, okay. Grid underscore type. So we want to find every instance. Oh, actually this doesn't break anything. I'm just looking at this now. It doesn't break anything because it references the X and the Y. So we're only adding a Z and that's it. We're not breaking anything. Unless one of them is thrown in as a parameter to a function, which it shouldn't be because of the global variable. Okay. Alright. Alright. I think we're good. Cube grid. Just double checking. Twist type, float P, vector 2, call prime, all that. Okay, so unless there's something that I'm missing, which is a good possibility. So right in here, okay, so now what we want to do, grid base equals grid type dot Z. All this just so we could do that. So that gets sent in by the color in the R, but in the vertex shader we change that to grid type dot Z. Okay. And then I think we're good. That's the only instance of grid type dot Z that we need to do in the entire shader. It's only applied when, oh, grid type is 7, but we don't even check for that. We don't even care because nothing else uses it. Okay. Let's see what that does. The crystals should look a little bit more. Let me see. I don't see the asteroid field. Is there an error? No? Whoops. Maybe it generated further out than I went. I don't see the asteroid field again. Where is it? Where is it? Are we missing it? I don't see it. Grid type dot Z. Well, before we do that then, let's just hard code it as 8. Let's make sure it works. There we go. Yeah, that looks better. That looks better. I really like that better. Because, how can they progressively get smaller? I thought it was supposed to be random. But I like that because they look more realistic like asteroids, rather than whatever they looked like before. But that looks kind of cool. Maybe this asteroid field had a, yeah, so I wonder why they do that. But, so the grid type Z is obviously not getting the value that we want. So grid type in right there, 1, 2, 1, out grid type. Grid type vector 3, agst.xz, acolor.r. And here, they're all 8 when you look at the moon. Excuse me. They are all 8. So the color RGB, right? So then here, a color that's coming in. Grid type equals vector 3, agst.x and z. Everything else is working though. Except for that in this particular, R color equals A color. But I can hard code it and it works fine. Yeah, see, these look a lot better out here. These look a lot better. Because it looks more like space. Yeah, I wonder why the size gets smaller as we go around the thing. I mean, it's kind of a cool effect, but I did not intend that. So there's the moons, create asteroid field, radius, color, angle, size. Grid size type, 24 plus random 24. This music is really cool. Oh, for each next asteroid? Oh yeah, there's the color there, but... Oh wait, I'm putting this in for the moon. Whoops. We wanted for the asteroids. Oh, and they do use a color. Hold up, they do use a color. Oh shoot, they do use a color. I forgot about that. Okay. So aside from putting the color as an area in the shader and then just sending in an index to the color. Oh, that might work. So, this is the color. So that's why hard coding it works, and then not, yeah, okay. Alright, so they have a 2D position, but everything has a 2D position, and when we send that in, so... Oh, wait. No, this, no, because it uses the color. That works for the moons because they use a texture. We can throw it in we have 3 extra floats for the moons, but not for the asteroids because they do use a color. So what would be involved in putting in a 3D position, a 3... Do you want to do that? We can just throw in a Z. For now, let's just leave it hard-coded, because it looks great, in my opinion. In my humble opinion, it looks great. So over here, let me go over here. I legit do not understand why the size is shrinking. Point size equals AGSTY. Yeah, I don't know why the size is shrinking. See? I mean, it still kind of gives an interesting effect, so I'm going to keep it. But eventually I would want to look at that. Okay. Okay, so we adjusted the asteroids. I'm satisfied with that. Actually, we have something to write in the devlog now. Where are we at? July 4th. Was that the last time I did anything here? I don't know. July 10th. So we adjusted the asteroids. The only thing we changed was class planets 140, space planets 121 VS. So 140, what did we do? We didn't really do anything. We messed with the moons and realized we were trying to mess with the asteroids. So we were basically an idiot. And didn't change much? Or we did, or we didn't. Yeah, no. See, this is the size right here. 24 plus random 24. For some reason, that keeps decreasing as we go around through this loop, through this I loop. Why would that do that? That's weird. That's just bizarre. There's nothing else that affects that. Grid size type, right? There's the grid type. Interesting. Okay. Whoops, wrong button. So then the only other thing I changed in 121 was I made AGST a vector 3, and I threw in the A color R, thinking that that would work for the asteroids, but that's what breaks them, in fact, because a super small number that's not an integer is going to be their size, which makes them display as 0 size. So we could literally go back to the other one and just hard code the 8 in the shader. But for now I'm going to leave this because we might want more, we might want another float variable or something that we could mess with, but I don't know. So that's alright. We broke stuff. It's okay. See, there's only moons and planets that use graphics so far. Everything else is shader code. Yeah. Excuse me. Okay, so we adjusted the asteroid. They look a lot better. They really do. Maybe fix aurora on certain planets. Okay, so let's see. Which planets are messed up? Which planets are messed up? We should probably print out all 69 of them to see, but I think it's just these guys. See, each one of these, which... Let's go look at the graphic real quick. Computer. It's scanning my hard drive. There we go. Miscellaneous? Yeah. So, here we go. Okay, so it's these ones, and then it's all these ones here. Of course, they're not grouped together. What the heck? Did you not realize that when you went to do this? Wow, Jeff. Just wow. That's all I have to say is wow. Okay, so I don't think there's anything that I do. Planets. No, that's going to be in here. So when we're drawing one of those, minimap, texture, the texture, temp text, texture, this is it right here. XF, YF, that's offset. Okay. Temp text equals texture, XF times mod, grid type X7, YF times that. Okay, plus, okay, here's the thing right here. X times XF, Y times GL point coord. Okay, so we just want XF to be slightly smaller when we're doing that. XF times, that's the offset. Oh, so we're using it as the offset and the size as well? That's weird. Because grid type X excuse me. Oh, right. It's actually all of them. Okay. So let's just make another, let's see. That's like 2 pixels. And in the Y direction, that's not quite 2 pixels. Let's see if that makes the planets look any weirder, or the moons. Oh, it cuts them off. No, it doesn't. Yeah, that's just what yeah. Let's go like this, size. And then down here when we're doing this, so this location here, excuse me, this location here is where we reference into the texture to start sampling. And then this is the size of the sample that is taken from the texture. Okay, alright. Couldn't highlight it. Visual Studio messed me up. Alright, give me the mouse. Alright. Oh, yeah. But that one looks okay. It's got... These look all alright. That one's still got the aurora. Okay. So should we make the thing... That's 2 pixels. Let's go... times 10. So 20 pixels. Let's actually see the difference. Oh, yeah. Oh, I see what it's doing. Yeah, okay. They all look like a weird... Too much, obviously too much. So let's just go times like that. So that's 4 pixels. Okay, those look good. That looks good. That one looks good. Was that one... Did that one have Aurora before? It has a slight thing on it, but otherwise, yeah. That one has a slight thing on it. Now the other thing we could do, hold on, let's just redo this line. Computer, what was that? Visual Studio totally breaks down when it comes to inside the fragment shaders. Excuse me. XF. Let's just put this back. Okay, so then there's that, and then what was I thinking? Oh yeah, then I wanted to actually just go... Oh, it's actually not... Oh. Wait a minute. Let's put something like this in here. Did we break it? What are we doing here, Jeff? I thought it was, it's not shown. Oh, there we go. There we go. You know, I think that'll work. I think that's going to work. Let's look at more of them. We should just hard code the number of planets. Did that solve our Aurora problem? Cool. I think that did, yeah. See, these, they're much sharper. And there's no, it's not sampling outside of a circle, the circle now. Because these are actually bigger than, see, like, where is it? Let's actually look at it. Excuse me, boy, that carriage is cleaning me out. Feels good. Because these are actually of the full grid size. So if I cut that back and make it a perfect circle, that's getting a really sharp edge. Versus everything else is not getting cut off, it's fine. Even these ones are smaller than the big ones. And then these ones, there's some baked in lighting which actually gets cut out, which is kind of cool. So I think that works. And what was my... Yeah, see, 0.4. So it's not even 0.5. Like if I go to 0.5, I bet you'll see the auroras and stuff. And it won't be as sharp. See, the auroras are back. Okay, so let's go to 0.4. I like that. It's a good number. It's a good number. Yeah, see, they're really nice now. Okay, that's great. That is good. Have you got no moons? Looks like the board. Why did these go so small? That's hilarious. I don't know why. I totally didn't do that. It's not supposed to. But anyways, I wonder why they do that. Maybe fix Aurora. We got it. Okay. Warp zones, minimap, ship size. Okay. Ship size is an interesting one. I hadn't thought about that. But, I mean, I obviously looked at or noticed it. It's just the ship looks huge. If you look at the ship in reference to the planets, the ship is huge. So maybe half the size? Like, see, look at the ship in relation to this planet. We're not going for realism, but we're going for proportion, I guess. So the ship is actually in here. Class ship 113. Let's leave the planets. Let's clear up some of the space here so that when I load this, we can actually... There we go. Class ship 13. And we're probably going to save this to 14. Because I'm sure we're going to break it. 14 exists. Son of a bean dip. 15 exists. What? How many of these exist, Jeff? I have no idea. 16. How many ships we got? Dang, what? Alright. Let's do this another way. No, let's just keep going. 19. There we go. Sheesh and Chong. Sheesh and Chong. Okay, so let's go class ship 119.h. Shrink ship. Boop 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 boop. Alright, 228. I kind of want to just bump that up now too. We're actually going to another version, 229. Which means we go in here. Main, space, gems, 229. Shrink, ship. Okay, now we're taking this out. Remove. Remove. Okay, class ship 119, class ship 119. Okay, so basically we do this init data, initialize cargo, manually draw the ship, and it does this. What we could do is go through and apply a scale. Because it centers everything around 0. Initialize cargo and credits. What are you doing there? Ship verts 0 through 15. Is it going to be that easy for me though? So ship verts. So, and that's all positions. Okay, great. So ship verts I times equals what no what did I say? Okay, 0.5. Would that do it? I think so. Let's try it. Let's try it. Didn't break anything. Oh yeah. Oh, it's smaller. Oh, that's cute. Is that a good size? Do you think that's a good size? I think it's a good size. It's right between the size of a moon and this. It's the size of this small planet. Hello, I come to take over your planet. Actually, I just hide behind your planet. Now your planet has a weird... I'll hide behind this one. Floop. Bloop. Okay. Alright, very cool. Okay, we did that. Ship size, I'm happy with that. We like it. I'm happy with it. We're good. Ship size. Bingo. Down. Okay, warp zones or minimap. Okay, no. Let's start with the minimap, I guess. I guess. So it's in planets here. Bum, bum, bum. So init data, star, Asteroid field, choose color, even distribute, warp zones, minimap. Okay. So when it comes to the minimap here, okay, what we want to do, the minimap is a special one. So we need a variable for this. Minimap variable, minimap I equals 0. We already have that. So why aren't we using that? Have I used that before? Well, let's put it in down here. Mini map I equals SSPT index. We want to save that index spot. So does it? Did we does it? Mini map I. No, I didn't even use it. I set it up. I was ready, but I didn't do it. Okay. So then the only thing we have to do is position it properly, size it properly, and then in the update function, that's the only one that we don't want to update. Where's update data? Points to render. Okay, so we're going to do this. We have to put in an if statement now because we have an exception. So if I is not equal to mini map I, then you can do that. Okay, so that will do that for everything. So right now the minimap will not move. Let's verify that that's true. Okay, minimap will not move. Right, so as we're moving around, the minimap is not going to move, but everything else will. What does that one look like? Oh, that one looks funky. We might not have... it's a glitch. That looks weird, but we'll keep it for now. That's interesting to see. Okay, so there, so now we just need to position it properly, and size it properly. 256, let's go a little bit bigger, twice as big. The position, we want it to be 7.5, negative 7.5. I don't know if that's right, but we'll see. We'll see. Okay. Could come up a little. Come up a lot and then move over slightly. Okay, so come up a little. Let's go to there and move over slightly. Okay. Okay, come up a lot more. Come up. So let's just go 5.5. Boy, that it just but that's just circles. Okay. Alrighty then. Little more. Little itsy more. Itsy bitsy. There we go. Perfect. Is it too big? We can toggle it on and off. I think it's too big. What's minus 128? 384. You'll have to move it down. See if that'll do it. There we go. Is it tucked away in the corner enough? I think we should move it over a little bit more. There we go. That looks good. There's still room on the sides. I like the feel of that. I think that's where it was and the size it was in the Space Arena too. Okay, so I think we're good with that for now, the mini-map. It doesn't work though, so let's leave that on there. Warp zones. I think for now we did a little bit of adjustments, we did a little bit of whatever. I'm gonna stream later. Oh, we already have warp zones figured out. We already have the minimap figured out. Around further out would be the outer zone, flowers, crystal shapes. Okay, check for save file. One solar system. We got all that. Check for save file. Okay. So let's move the save file up, because that's going to be very important. But move the warp zones up as well. So once we get the warp zones set, We can either do the save file or the mini-map. I'll do this later. I will stream later. Don't know if anybody was streaming, but thanks for tuning in. Thanks for stopping by, saying hi. I'm going to put this on YouTube, and away we go.